Okay, so let's get right into it. How do you build an AI that you can actually trust? I mean, not for writing poems or making funny pictures, but in a really high stakes place like a hospital or a lab, where getting the right answer every single time is absolutely critical. Well, today, we're going to break down a blueprint for exactly that, a totally local, private, and audible AI system. So here's what we're going to cover. First, we'll kick things off with the big problem this kind of system is designed to solve. Then we'll unpack the core technology, something called RAG. After that, we'll pull back the curtain on a real open source system, see what makes its document handling so darn smart, and then cover the absolutely crucial elements of trust and security. And finally, we'll talk about why this whole local approach is such a game changer. All right, so let's set the scene. We're talking about places where information isn't just data, it's basically a set of life or death instructions. Think about a surgeon's checklist or a safety protocol in a high-tech lab. In that world, there is literally zero room for error. Just picture this for a second. You're a lab technician, and you need to find one super specific step buried in a 100-page standard operating procedure, or SOP. Or maybe you're a nurse, and you need to find a critical warning inside the instructions for use, the IFU, for some complex new medical device. You don't just want the right answer. You need it, and you need it now. And that right there is the heart of the problem. These documents, SOPs and IFUs, they are incredibly dense and super structured. They are packed with essential stuff, warnings, cautions, very specific numbered steps. A simple keyword search, that's just not going to cut it. And misinterpreting even one sentence, that could have some really serious consequences. So how do we build an AI that can handle all this complexity and do it reliably? You might think the answer is just a bigger, more creative language model, but nope, that's not it at all. It's about making the AI smarter and more grounded in reality. And that brings us to the core technology here, RAG. RAG, which stands for Retrieval Augmented Generation, is a pretty genius idea when you think about it. Instead of just letting a big language model guess or, hallucinate an answer based on everything it's ever read, you give it an open book test. You force it to look up the facts first. It retrieves little snippets from your trusted documents, and it uses only that information to generate an answer. And this is where you can really see how that flow works. A user asks a question, but the system doesn't go straight to the AI brain. No. First, it goes on a little fact-finding mission. It searches a dedicated library of your documents, called a vector database, finds the most relevant passages, and then it hands that evidence over to the language model and says, here are the facts. Build your answer from this and only this. Retrieve, augment, and then generate. So, okay, theory is great. But what does this look like in the real world? Let's move from the what to the how and look at an actual open source project that's designed for maximum privacy, control, and of course, security. The system we're going to be digging into is called MyRAG System. It's an open source project you can find right on GitHub. And it's just a perfect case study because it was built from the ground up to solve that exact critical document problem we were just talking about, specifically for clinical environments. And here's the magic trick. The local first philosophy. Every single component you see here runs on your own hardware. Your documents live in ChromaDB, on your server. The brains of the operation, the LLM, is run by something like Ollama or vLLM. Again, on your machines. Nothing ever leaves your building. No data is sent to some third-party company. It is a completely private, self-contained ecosystem. Okay, so the system is self-contained. That's awesome for privacy. But how does it actually understand the documents you feed it? I mean, this is where the real intelligence comes in. And frankly, it's a step that a lot of other systems just get wrong. I mean, really think about that. You've got this massive 100-page manual. How is an AI supposed to find that one critical sentence? You can't just feed it the whole thing at once. That's not how it works. You have to break it down into smaller pieces or chunks. But how you do that chopping? Well, that changes everything. And you can see the huge difference right here. On one side, you've got standard or dumb chunking. That's like taking a pair of scissors and just blindly cutting the text every 500 words. You could slice a sentence or worse, a critical warning right in half. But on the other side, you have intelligent semantic chunking, which is what this system does. It reads the document like a human would. It understands headings, numbered lists, and it knows to keep important things like warnings and cautions completely intact. Yeah, this is the perfect way to think about it. One method just destroys the context. It's like ripping pages out of a book randomly. The other method respects how the document was written in the first place. It's like neatly separating a book by its chapters. For documents where the structure is the meaning, like an SOP, this isn't just a nice to have, it is absolutely essential to get it right.
All right, so our AI is smart. It understands context. That's powerful. But in a clinical or a regulated world, powerful isn't enough. It also has to be trustworthy. It has to be verifiable. And it has to be rock solid secure.
And this right here is the first pillar of trust: transparency. Every answer the system gives you doesn't just appear out of thin air. It comes with footnotes. It tells you exactly where it found the information, the file name, the page number, even the specific section. This means a person can always go back and check the source. And for accountability, that is non-negotiable. Which leads us directly to the second pillar, security and compliance. Because let's be real, it's not enough for the system to give you correct, cited answers. You have to have an irrefutable log of everything it does. Who asked what? When did they ask it? What did the system look at? This is the kind of audit trail that regulators and compliance officers need to see. And this is how this system nails it. It doesn't just write to some simple log file that could be edited later. It uses something called hash-chained audit logging. The easiest way to think of it is like a mini blockchain just for the system's activity. Every single entry is cryptographically sealed to the one before it, creating a chain that's impossible to tamper with. You can prove that the log is pure and hasn't been altered.
Okay, so let's just zoom out for a minute. We've talked about the problem, the tech, and a real working system. So what's the big takeaway here? Why does all this matter for the future of AI in these really important fields?
Well, what we're looking at isn't just one cool project. It's a full blueprint for building trustworthy AI. It checks all the boxes. 1, it's totally private because of local control. 2, it's smart about the specific documents it handles. 3, it's verifiable because every answer has a citation. And 4, it's secure with that tamper-proof audit log. It is the whole package. And really, this points to where all of this is heading. For so long, the conversation around AI has been focused on the risks, data leaks, hallucinations, a lack of control. But when we start building systems on a solid foundation of local control, of verifiability, and of trust, well, that changes the entire conversation. It's no longer about what could go wrong. It becomes, what are the incredible problems we're finally going to solve?